Alright, we've been evaluating composite functions at particular values of x, but we need to be able to find an actual function format of the composite function that we're looking for. Then we can use it. We don't have to go through the process every time. We can use the function itself. So if we have two algebraic functions, f of x and g of x, so we want to be able to do two things. We want to be able to find f of g of x. We also want to be able to find g of f of x, because those are two different things. Okay, so f of g of x is on the inside. We're going to take all of the function g and substitute it into the x in the f of x function. So we're going to have the 2, but instead of writing the x, we're going to put in the 5x plus 1 and then minus 3. So we're writing all of this, the 2x minus 3, except we're replacing the x with the g of x function. And then it's just a matter of simplifying the algebra. We want it in simplified form. Okay, so then that's going to equal 10x plus 2 minus 3, and combining our like terms would be 10x minus 1. So that would be f of g of x. But if we need g of f of x, we have to do it the other way. We're going to be taking the entire f function and putting it into the spot, the x position in the g function. So 5, instead of where the x is, we're going to replace it with the 2x minus 3, and then simplify the algebra. So 10x minus 15 plus 1, we're going to combine our like terms to 10x minus 14. Okay, so this one is f of g of x. This one is g of f of x. Okay, got 2 more examples for you. Try to keep this quick. So just some different things that can happen with the algebra. So if I want f of g of x, I'm putting g into the f function. Okay, so dang it, so sorry. So we've got 3 times x squared plus 1 plus 6. 3x squared plus 3 plus 6. 3x squared plus 9. Now if we're doing g of f of x, we've got, this time we're putting f of x into g, so we've got 3x plus 6, the quantity squared, plus 1. Now that takes us to that squaring a binomial process. Remember, we should be able to, it's been a little while since we've done that because we've been doing other topics, but so square the front, 9x squared, multiply the two terms and double it, so 3x times 6 is 18x, doubled is 36x, and then square the back, which is the 36. Then we've got the plus 1. Okay, square the front, multiply and double it, square the back. That was the process that we'd studied before, a long time ago. Plus 36x. Combining those like terms at the back, we've got, 37. Okay, if you don't remember that process, then you have to write out 3x plus 6 times 3x plus 6 and do the whole FOIL process. Okay, but if you've done enough of those, you should be able to remember that. And the last example that I have for you here is, so f of g of x, Okay, it means we're putting g into f. So square root of x squared. Now remember, squaring and square rooting are inverse operations. When you square a square root, you just get what's inside. Okay, you square a square root, you just get what's inside. That's it. So don't panic when you see all these exponents. If you have g of f of x, now we're putting f into g square root of x squared plus 4. That does not simplify. Okay, just on an aside up here, you cannot just square root each part. Okay, that is not the same as x plus 2. Okay, because you cannot just square root each part on that. So that does not simplify. It's not a perfect square. All right. So some examples there. You have a short worksheet to do practicing just a couple of these problems.